Good morning, students. So, till the last session, we studied about motion. We understood the definition, the concept of motion. We understood the formulas which we use for calculating speed, distance, time. We got to understand the unit for speed. On that basis, now we are moving forward, and what is the main objective for today, for the last session of this particular chapter, is here we are going to learn about the two different types of motion, which is uniform and non-uniform motion, and we will be able to also learn the graphical representation of the uniform and non-uniform motion. So, as we already know what motion is, whenever an object moves from one position to another position, then we state that the object is in motion. In that perspective, we have two different types of motion. One is uniform motion and another one is non-uniform motion. Now, when I say uniform motion, whenever a body is moving in a straight line, okay, a body is moving in a straight line and it is covering equal distance in equal time interval. That means the distance that it is covering, say from 0 to 2, after 2 it is covering the next 2 centimeters or meters, say 4, okay, and the time interval is, say, after 1 minute I calculated the distance, that was 2 meters, after 2 minutes I calculated the distance, it was 4 meters. Okay, so the distance that the body is traveling is equal with equal interval of time. Then such a motion is called as uniform motion. Whereas non-uniform motion is opposite to it. Now, when a body is covering unequal distance, so at times maybe it is covering 1 meters, and after 1 minute, after 1 minute, I'm seeing that the body is covering 1 meter. After 2 minutes, I see that the body has covered 5 meters. Okay, so therein what is happening here, that the body is covering unequal distance in maybe equal interval of time, or it can be vice versa. That means it is covering equal distance in unequal interval of time. Then we state that the body is showing non-uniform motion. Now, based on this, the next that we are going to study over here is what is average speed. So till now we studied about speed. Okay, now here when we come to the concept of non-uniform motion, and here as we are saying that the body is traveling unequal intervals, okay, at unequal intervals, unequal distance. Okay, so here say the body has traveled from point A to point B, say 2 kilometers, and after that from point B to point C the body has traveled 5 kilometers. Now I need to find out what is the speed of the vehicle, of the body. Okay, so here I have got two measures of the distance. One is 2 kilometers and another one is 5 kilometers. So whenever I have to calculate the average speed, I need to find out the total distance that the body is covering and the total time that the body is taking to cover that distance. So I'll add up the distance, okay, the distance measure, and I'll add up the time measure, and the same formula again for speed, wherein speed is equal to total average speed is equal to total distance covered upon total time taken. So why total distance? Because here unequal distance is being traveled at unequal interval of time. Okay, or maybe at equal interval of time, but then unequal distance as it is being traveled. So here we need to do the sum, find out the total distance that the body is covering and the total time taken by the body. So let's try and solve one question which is given to us based on this. So here we have a question wherein we have to calculate the average speed of the bus. So let's try to find out first. A bus travels 5 kilometers for 2 hours till point A and continues to travel for 8 kilometers for 4 hours. Okay, so here we have got the measures for distance and we have got the measures for time. And if you see, we have got two different datas over here. And on the basis of that, we have to calculate the average speed. So as I explained you in the earlier numerical sums, first of all, we write down the statement, the given data. Okay, so first I will write distance traveled by bus till point A is how much? It is 5 kilometers. Okay, and then time taken is how much? It is 2 hours, followed by distance traveled for 4 hours. How much distance is the bus traveling for 4 hours? That is 8 kilometers. Okay, and the time taken to travel 8 kilometers is how much? The time taken is 4 hours. Okay, now I have got two distance measures, I have got two time measures. So what I'm going to do is I'm going to find out the sum of the distance and the time. So I'll write here total distance traveled, which is equal to 5 plus 8. Okay, so 5 plus 8 when I do, what is the total? 5 plus 8 is equal to 13 kilometers. And then I will take total time. Total time will be how much? It is 2 plus 4. Okay, so 2 plus 4 is equal to how much? 6 hours. Now I know the formula for average distance. So average speed. So average speed is equal to total distance upon total time. Okay, so here what's the total distance? 30 divided by 6. So what is the answer that I get at the end? I will get the answer as 2.16 kilometer per hour. Okay, so that's the average speed that the bus is traveling. Clear? Okay, so here as we discussed about uniform, non-uniform motion, and based on that how to calculate average speed, now comes the time wherein we need to graphically represent and understand whether my object is moving in a uniform motion or in a non-uniform motion. So graphical representation helps you in understanding whether the motion of the body is uniform or non-uniform. So here you can see that I have placed in front of you a graph. Okay, so first we'll try to understand the basis of how the graph is formed, and then I will show you how a uniform graph and a non-uniform graph is formed. Now, when we talk about the distance time graph that we have to plot in over here, so we have a graph paper with us. Okay, now here you can see these two lines. One is a vertical line and the other one is a horizontal line. Okay, now, the line which is horizontal line, it is called as the x-axis. What is it called as? X-axis. And the line which is on the vertical side, that is the vertical line over here that you see on the left-hand side, it is the y-axis. Okay, so the name of the axis is x and y-axis. Now, as we are here plotting the values for distance and time, okay, so we need to decide on which axis is my distance going to be placed and on which axis the value of my time will be placed. Now, now you can see here clearly on the graph that I have placed distance on the y-axis and time on the x-axis. Okay, so this distance and time that here we are talking about, these are two variables, okay, two measures, two datas, and out of that, one is a dependent variable, that is distance, and one is an independent variable, which is time. Okay, so here as you can see on the graph, distance I have written it on the y-axis and time I have written it on the x-axis. Okay, so whenever I am writing whatever term that I am writing, measure that I am writing on the y-axis, it is always going to be a dependent variable. Okay, a dependent measure. Whereas whatever value or measure that I write on the x-axis, it is going to be an independent variable. Now, independent and dependent variable, what do we understand by that term? Now, when I say independent variable, that means time is not bound. It is not going to be dependent. It is not going to rely on any other value. Whereas when I talk about distance, okay, distance I'm going to measure with respect to time. So as the time interval is going to change, I am going to measure what the distance that is being traveled by the body. So the distance measure is going to change according to the time interval. That is why here we consider distance as an dependent variable, whereas time as the independent variable. It does not require any other measure to be. So distance is always measured based on the time interval, and that is why it is considered as a dependent variable. Okay, now the next question over here. Now whenever I have to place in the values, okay, whenever I have to plot the values on the x and the y axis of the graph, the first thing that I need to understand is the scale of the x and y axis. Now when I say scale, okay, you can see here the darker green line, this whole box, this whole line, okay, from the origin. So here, this point that you see where the two x and the y axis are joining, intersecting together, this point is called as the origin point, which the value for it is considered as 0, 0. Okay, so from 0, when I calculate, till the first line that you see, the darker green color line, this is considered as 1 centimeter. What is it considered as? 1 centimeter. Whether it is vertical, whether it is horizontal, both ways, both sides, it is considered as 1 centimeter. Now, when I am choosing the values that I have to place, now always remember, I cannot randomly write any number that I want on the graph. I have to decide the range. I have to have a uniformity while I am making the graph. Whether it is a non-uniform motion, whether it is a uniform motion. So whether the distance is an equal interval or the distance is not an equal interval, both the graph always will remain, the range of x and the y axis will remain in uniform order. Okay, so if I am writing 1, 2, 3, 4, that means I am giving a difference of 1 to each range. Okay, but then if I am taking the range, say 10, 20, 30, 40, that means here I am giving the difference of 10 to each scale. Okay, so here what you need to remember over here is that each line, each darker green color line that you see, one from the origin, then from next from one to the second, they all are measured as 1 centimeter. And then it depends on what range or what value am I taking on the graph. Based on that, I will decide whether I have to take the range of the difference between either 10, maybe at times I can take the difference of 2. Okay, so 2, if I say, that means my 1 centimeter will be considered equal to 2 units. So after 0, I will be directly here writing 2 followed by 4. That means after every unit, there is the difference of 2. Clear? The same goes for the x or the y axis. Okay, so let's try to understand how the graphical representation is done over here. So as we have already discussed, the x-axis and the y-axis needs to be plotted on the graph. X-axis is named as time, y-axis is named as distance. And as earlier discussed, we need to plot the values for time and distance in uniform order. Okay, so for example, for time, I am taking, so for one, what did I say? 1 centimeter now here is going to be considered as 2 seconds or 2 units. Okay, so every 1 centimeter, if you see, there is a difference of 2. Whereas when you come to the axis, the y-axis over here every 1 centimeter, if you see, is equal to 10 units or 10 meters. Okay, so every 1 centimeter you see, it is having the difference of 10. Okay, so see, y-axis, there's a uniformity, no abrupt numbers have been written in between. Uniform range is being mentioned on the y-axis, even on the x-axis. And then as we plot the numbers on the graph, so first 2 is what is the distance after 2 seconds? It is 10. So we plot or place a dot on that particular intersecting point. The same goes for the further points. Okay, and when we join all the dotted lines together, I see that there is a straight line which is formed. This straight line easily states to us that the motion that the body is showing is uniform motion. Clear, everyone? Okay, now let's move on to the next representation, that is the non-uniform motion. Now when we come to non-uniform motion, let's first see the table which is given to us for distance and time. So if we come to distance and time, what do we see over here is distance that the body is traveling is equal. Okay, that is 5, 10, 15, 20, 25. That means that there's a difference of 5 every time. But then when we come to time over here, okay, the time is not equal, it is unequal. So as we defined non-uniform motion, so as we defined non-uniform motion earlier, so either unequal distance and equal interval of time, or equal distance and unequal interval of time. So here if we see 2, 6, 8, 15, 20, there is no uniformity at all in the time interval that they have taken to measure the distance. So in the same way, when we are plotting the values on the graph, okay, as we are plotting, as we are placing those values on the intersecting points, therein what do we see is that the line that here it is formed by joining all the points together is not at all straight, because there are 2 points or more than 2 points which are falling outside the line, either on the left hand side or on the right hand side of the line. Correct? So hardly there is any point which is intersecting with each other. So this clearly states that the motion that you see over here of the body of the object is a non-uniform motion. Okay, so as at the end of the whole session, at the end of the entire chapter, what all things have we learned till now from this? We are able to define what is time. We are able to decide why the standard measurement was required. Multiple sub-multiples of unit we studied about. We are able to convert the larger quantities to smaller quantities of in conversion of time, smaller to larger quantities. We are able to define what is speed, what is motion, what is rest, what is average speed, how to calculate speed, distance, and time. And based on that, we got to also learn about 2 different types of motion, uniform and non-uniform motion, and the graphical representation of the same. And as I end the lesson for today, there is again an assignment that I am leaving with you all, that you have to solve in your notebook. So these are the 2 questions given to you based on motion, based on maybe the calculation of speed, distance, time. So that is something that you have to complete and solve in your chapter. Thank you, students.